Welcome and thank you for joining us today for Big Data Driving Rail Decisions, some real-world examples and case studies on how big data is being used in the rail industry. Thank you for joining us. Please note if you have any questions during our presentation in the lower right-hand corner, feel free to enter your questions and address both of our speakers today. Steve Tautz is a co-founder and CFO at Lat-Lon, as well as a longtime rail enthusiast. As resident expert with Tableau data insight software, Steve has been able to dive into massive amounts of data from customers while offering context from real-world experience in facility management systems. Steve holds a double major in civil engineering and in business administration from the University of Colorado and is a member of several trade organizations. Brendan Shaw, our second speaker today, is a senior executive at BSM and industry expert in IoT functionality. He has built a career on consulting with Fortune 100 companies. His focus over the last 7 years has been collaborating with most Class I railroads. Brendan has ingrained himself in the priorities of some of the largest fleets of rubber tire and high rail vehicles in the rail industry. He offers proactive insight into rail objectives like safety, utilization, and more. Brendan sits on the board of several startup IoT companies and is often asked to be an industry speaker. Thank you very much for speaking today, gentlemen, and here is Steve.
Good afternoon, everyone. I'm going to go to my first slide. The real objective here of this talk today is how to take mountains of data, just rows and columns, and turn it into decisions that we can use for our day-to-day business. The Internet of Things is been collecting data now from various devices for the last 10 years, and so we are collecting data from everything from mobile assets, stationary assets, people, employees, possible assets in rail yards, and we're now collecting it seems like mountains of data. We have many different data sources that we can use to evaluate. Right now, BSM and Lat-Lon is collecting over 36 million messages per day. It adds up to about 8.6 gigabytes of data. And that data also equates to over 13 billion messages a year, or 3.3 terabytes of data. So it's a lot of data, and there's also other data sources that you can add to that type of information. There's lots of free government data that's out there. There's weather data, there's census data. We're also interested in other logistic type data like RFID or CLM type data, also track data. And then there's all sorts of other business data that might also be useful in CRM systems or Salesforce, or facilities data, or just possible data that's on an Excel spreadsheet or other company data that's being gathered. So the real key is pulling all these data sources together into a master database that you can analyze. There are lots of different types of visualization tools available. We provide web applications, mobile apps, standalone apps that run on your computer. Also, Microsoft Excel. We use a program called Tableau, and a lot of the examples I'm going to be showing are going to be from Tableau, and I'll speak more about that in just a few minutes. There's also a lot of competitors to Tableau, Chart.io and Focus, and etc. And then there's also a lot of tools that are available from the big guys as well, and I've just listed a couple of them here. The first thing that I'm going to talk about is impacts, and this is a graph from Tableau that takes a customer's data and displays it by month, by state. And one of the things that Tableau does very nicely is it creates a heat map, and a heat map just means that the colors change on a map based on a variable. So in this case, not very many impacts is kind of in the green color. As it turns to yellow, you get some more impacts, and the most number of impacts is in the kind of the brownish red. And so you can see here, you know, some states are, you know, don't have any impact, so they just show up as clear, and other states will be, you know, more of a darker color. So another way to slice this data is by the magnitude of the G-force. And so at the top graph, we have the number of impacts, which is from the previous slide. And on the bottom, we have the impacts that are geolocated, and they're also have a color associated to the magnitude of the impact. So here you can clearly see that there are a lot of green impacts along road routes, and then you see kind of more pink and even red ones that are concentrated, and those tend to be at rail yards. The other thing that Tableau does a nice job of is you can also vary the amount of data by color, but also by transparency or saturation. So you can see that that some of those circles are kind of a brighter red than some of the pinker ones, and that just means that there are higher magnitudes of impacts in those areas because they're more saturated than the other areas that you can see. So next I want to kind of drill down into some more specific data, because this is still the data for the entire fleet over the entire country. So next, let's take a look at Texas. And Texas, you can see that there is a green line that is dispersed, which are kind of road impacts, and you can see some pink areas where there is more concentration of impacts in El Paso and kind of around the Houston area. So one of the things that you can continue to do is drill down in the data. So now let's take a look more at the Houston area. And this is a map of Houston. There are a few road impacts that you can see up along the upper right-hand part of the map, but you can clearly see that most of the impacts are concentrated in the yards that are around Houston. So I'm going to drill in even further to the rail yard that was the vertical north-south rail yard, and you can see all the different impacts in this particular rail yard. A lot of good statistics come out of this. You can see that the average impact per unit in this rail yard is 4.4 Gs. The average speed at 1.5 miles an hour, and the maximum speed at 11 miles an hour. You can also see that the impacts are sized by well, they're different sizes and different colors, so you can kind of get a visual look at the size of the impact and the location of the impact within this yard. And this particular yard, you can just see that there's a couple fairly large impacts towards the north end of the yard. And so if you wanted to continue to drill down even further and get a date and time and impact values from this, you could do that. But I don't want to keep spending too much time on this. I want to show another example. And I'm going to now switch to a fuel graph from a locomotive. And this is just an Excel look at the fuel level in a locomotive, and there's a lot of things that you can see on this particular graph. On the left-hand side, the line is fairly straight, but you can see that the fuel actually kind of goes up and down and up and down and up and down. Well, that is actually the daily temperature fluctuations causing the fuel to expand and show that there's more fuel. You can also see that when the locomotive is moving, that you get more of a situation where the fuel is sloshing and the grade is changing, and so you get a much coarser look at the fuel. You can see where the fueling events are, and towards the middle of the graph, you can see that the line is fairly stable, but it's going down. And so as it's going down, you know that it's burning fuel there, and so there was 1, 2, 3, 4 days that locomotive was idling and doing no work. And so those are all interesting things to see from a graph like this. But now I'm going to, instead of drilling down, I'm going to kind of go up. And let's look at how the fleet is doing as far as fuel usage. This is a heat map or a heat table of the number of gallons of fuel that a locomotive has burned over a year's period, so month by month. The bottom graph actually shows, on the blue line is the gallons of fuel used per month, and you can see that during the winter months in January and February, and also November, December, there's more fuel being burned. The second graph here is the idle time, and on the left-hand scale is the number of days. So in this case, for this fleet, in January, the average locomotive idled, or actually was running, for almost 25 out of the 30 average days of the year. No, this is idle time. So it idled 25 days of the year, and this bottom line down here is the work days that it actually put in. So this is the days that the locomotive is moving and running. So you can see that the work that a locomotive is expected to get out of each month is approximately 5 days of use, and in this case it was idling almost 25 days for that particular month. So I want to take a closer look at the fuel usage, and this particular graph is one that on the left shows the distance traveled based on runtime. And so the locomotives that are in the upper left-hand section of this particular graph are the ones that are idling more than the ones in the lower right-hand side. One of the things that Tableau does is it puts a trend line. So it takes your data and it will automatically generate a trend line. And so this trend line is going through the graph based on all the points on that particular graph. The next one is the distance as it relates to the work, and the work again is defined by a locomotive that's running and moving at the same time. And you can see here that there's a pretty good relationship between the distance that the locomotive has traveled and the fuel that it has burned. There are some locomotives in the upper left-hand side of the graph, and those are the ones that were idling more than the other ones that are kind of lower down on the scale. So that kind of shows a locomotive on a per locomotive basis, which ones are working the best and which ones are not working quite as efficiently. So those were a couple examples that I had to show. The real trick is to get the whole picture, and just to review a little bit, it's collect the data, combine the multiple data sources, use good visualization tools to find the golden nugget, and create the the charts and graphs that are useful for you to make the decisions that you need to on a daily basis. And with that, I am going to turn this over to Brendan.
Great. Thanks a lot, Steve. What I thought I would do is kind of elaborate a little bit more on what Steve had brought forward as far as some of the big data components, and combine that with some of the things that we do in the rail space, specifically when it comes to some of the rubber tire type vehicles. So, there's a number of different saving points out there. Obviously, the largest is fuel, large fuel spend. The second is the utilization of assets, and we've seen a fairly significant reduction in both of those by using the big data and being able to use that in combinations with different components coming in from different systems. So things like fuel theft, idle times, and some off-road fuel tax, again, all play into combining different data sets and doing statistical information and providing that data back to our customers. So one of those here is illustrated in taking rail data from customers and pulling that data into our back-end maps, and then using some of the GPS-based information to locate where vehicles are. So we can basically look at milepost information, we can look at track data, and we can use that data for providing different sorts of ROI to customers. One of those big ones is fuel savings, and one of the things that we can actually do is we can determine where vehicles are on property and on rail. Based on the map here that you saw before, it's showing where vehicles are within that overlay. And then what we can do is drill down further and give specifics based on how much time is being used on an off-road basis, how much time is being idled, and how much PTO time is being used, and decipher that down per state. So that information can be used for fuel tax rebates for some of our customers. So again, we're taking data sets from multiple points and bringing all that data together to provide an ROI, in this case, an off-road fuel record. One of the other key components here that we can do using those similar maps is being able to map different repair facilities and let us know when vehicles are in those facilities for a given period of time. So vehicle downtime, which equates to utilization. Obviously, you want your vehicles to be out there doing work out in the field. So if a vehicle's in a service area for a given period of time, for instance, 72 hours, we can report out on that. We can send different sorts of alerts out to be able to capitalize on that data. So again, we're using data sources here of the repair facilities along with the GPS-based information on where vehicles are to encapsulate that information for our clients. The other one here is, again, another type of data feed. In this particular case would be fuel card information to basically look at fuel theft and IFTA-based reporting. So we can work with fuel card providers to pull in that information into the mapping tools and use the GPS location of where the fuel transaction took place along with where the vehicle is and set up different thresholds to look for potential fuel fraud. So if a vehicle is within a mile of a given location, we can basically send out flags and alerts based on that data. So again, in this particular case, we're collecting data sources from 2 or 3 different areas and being able to report out on that data. The final example that I have here is really looking at idling trends. Again, taking the information that we have in our system, comparing that some of the things that Steve showed earlier, we're able to give different idling patterns that we can then communicate out to the industry and put some industry averages together and work with our client base in order to bring down that industry average and work with them on the fuel savings aspect of things. So again, just showing a couple quick highlights of some of the different things you can do with the data and different data sources that you're pulling in. So at this particular time, I'm going to go ahead and turn it back here with the last couple minutes that we have and open it up to some questions.
Thank you very much, gentlemen.
I'll turn it back to you.
We appreciate all that you presented today. A few questions have rolled in, and I just want to clarify a few things. There's some questions about which programs are being used. If you guys could clarify your slides and where that data came from, please.
Okay, this is Steve. I used 2 different examples. All the graphs except for the one locomotive fuel graphs were Tableau, and the fuel graph was Excel, Microsoft Excel.
And on the BSM, the side that you just saw that I presented on the rubber tire side, most of that came from BSM's back-end system.
And next question, where and how long is the data stored?
I can take that one. This is Brendan. Most of the data here for our railroad clients is stored for anywhere from 5 to 7 years on our back end. So you can go back and get live historical data for a given period of time. There are also other methods of passing data across to other platforms, your own internal platforms, and obviously you can store that for as long as needed.
And then as far as data analysis, is this something that's provided to customers? Do you use this Tableau program? A little bit more clarification on that.
Okay, I can take that one. This is Steve. I recommend that anyone that has a big data analysis problem, they should use Tableau. Tableau is a tool that can sift through a lot of data. It's about 10 times faster than using some of the competitors' type of software, and it's really good at the visualization part of it. You can very easily create the heat maps and the types of graphs where an outlier in the data can be easily seen. You can see where a particular data point is out of place, or you can see patterns that start existing where you might see a linear line in a random sample. So Tableau is a real good tool for that, and Lat-Lon does provide some consulting services using Tableau. So if you'd like to know more, we can talk to you about that.
And one more question. Which programs are you using to get the data, or where is this data actually being generated from? And this goes to both of you guys, too.
Yeah, again, from a data generation standpoint, I'll take that, Steve. We have multiple sources that we pull data from. Obviously, GPS-based units on different assets out on the rail yards and on the rail track. And then we also import data from not only our customers, but other data sources. So the data comes from multiple sources, and we streamline that. And then, as Steve's been alluding to, using a BI tool to be able to sift through that data.
And then I think very last, I just want to wrap up real quickly, and someone did ask specifically if this copy of this presentation was going to be sent out, and yes, it will. You'll be receiving all the slides in a PowerPoint as well as a link of the recording tomorrow via email. If you have any additional questions, feel free to throw them out and we can answer them offline, but we respect your time and we appreciate you joining us today. If you do need to contact us directly for any other specific questions, feel free to visit our website at www.connectingrail.com, or you can reach out to Brendan at bshot@bsmwireless.com, Steve at stautz at lat-lon.com, and we greatly appreciate you joining us today.